Good morning, folks. Welcome to our talk. So today we're going to be telling you a story. This is a story of how we built the Chrome dev editor on the Chrome platform. This is our story for the past 8 months, and we'll try to compress it to the next 30 minutes. And along this journey, you will learn how to build your own awesome multi-device applications on the Chrome platform. I'm Sriram Saroop, a product manager on the Chrome team, and also the product manager for the Chrome dev editor.
Morning, and I'm Devon Carew. I'm an engineer on the Dart team and the tech lead of the Chrome dev editor.
Awesome. So what is the Chrome dev editor? It's what you see on the screen. It's a developer tool for building apps on the Chrome platform. You can build web applications. You can also build Chrome applications. You can write them in JavaScript or in Dart. The Chrome dev editor itself is built as a Chrome app, and it's written in Dart and uses Polymer for its UI. If you have no idea what Polymer, Chrome apps, or Dart are, no worries. We'll cover that in the talk. So being a Chrome app, the Chrome dev editor runs not only on Windows, Mac, and Linux, it also runs on your Chromebooks. That's right. So you can start building apps on your Chromebooks with the Chrome dev editor. So I told you that the Chrome dev editor is built on the Chrome platform. So let's define what the Chrome platform is. There are 3 parts to this. Firstly, Chrome apps. So Chrome apps really extend the web. They add new, rich, native capabilities that are not normally available to web pages. These range from accessing devices over Bluetooth and USB to getting access to the raw file system where you can read and write files to a user-selected folder. Chrome apps run cross-platform by default, and that's not limited just to desktop operating systems. They run on Android and iOS as well. We'll be talking about that shortly. So Devon, you want to talk about Dart?
Yeah, so what is Dart? Dart is a structured programming language for the web. It's class-based and object-oriented, and is designed to be familiar to developers. So if you're familiar with Java or JavaScript or C#, Dart will seem very familiar to you. It's also designed to be productive to write code in. It's statically analyzable and really amenable to tooling. So you can get errors and warnings as you type rather than at runtime or at deploy time. It supports good code refactoring tools so you can keep your code healthy when it grows large. It has a native virtual machine. So if you're running in a browser that has Dart support natively, you get that performance benefit. But it also compiles to JavaScript, so you can target, with Dart, you can target any modern HTML5 browser.
Awesome. So the third part that the Chrome platform constitutes is Polymer. Polymer really brings software encapsulation to the web. So with Polymer, you can encapsulate not only script, but also markup and styling. You can build your own custom HTML elements that you can reuse both within your project as well as across projects. In addition to the ability to build your own custom HTML elements, you now have access to a library of rich UI elements that we've made available called Material Design. And you can use these elements to make your apps much more beautiful out of the box. So the Chrome editor is built on these 3 pillars of the Chrome platform. Let's take a step back and tell you why we decided to build the Chrome dev editor in the first place. Chrome apps. So Chrome apps launched late last year, and we found some really impressive apps that US web developers had built. Ranging from an online DJ tool for mixing music to a fully offline capable video editing app. Amidst all these impressive apps, however, there was one category of apps that we did not quite see on the web store, and that was developer tools. That's right. So we didn't quite see many developer tools coming up on the web store, and we challenged ourselves to see if the Chrome platform can be extended so that you can build developer tools on it. And more importantly, we wanted to provide a great developer experience for you as web developers using the Chrome platform. So the Chrome apps team was playing around with this idea of building a prototype developer environment as a Chrome app, and this was around 8 months back, and that's when our friends in Dart had a similar thought process.
Yeah, so why did the Dart team get involved? So for some background, I work on the part of the Dart team that's doing the development environment, the Dart editor. And for those of you who don't know, most of Dart's tools are themselves written in Dart. We've got Dart's JavaScript compiler, which is written in Dart. Our Dart analysis tools are written in Dart, and our package manager pub is written in Dart. And a big piece that isn't is the part I was working on, the Dart editor. It's written in Java as an Eclipse application. So my team for a while had been thinking about ways that we could spend more time writing Dart ourselves and rehost our development environment in Dart. As we were working on the Dart team, but spending all of our time writing Java. And about a year ago, we heard about the Chrome apps platform, which really appealed to us because it was going to give us a way to write native-like applications in Dart, and basically it would give us the vehicle for writing our development environment in Dart. We're really excited about some of the features that the Chrome Apps platform gave us. We could run across platform on Windows, Mac, and Linux. We could target Chromebooks, which would be awesome. And it had some other time-saving features like auto update, which we could write ourselves, but because it's built into the platform, it would save us time. We could focus on more domain-specific features. And in addition, we were really excited about the possibility of writing our UI in HTML and CSS, because it would give us a lot of flexibility and sophistication and room to experiment with new UIs where our previous technology, we really didn't have that flexibility. So we were really excited we saw the Chrome, writing our IDE in Dart and building on the Chrome platform as a way of taking our tooling to the next level. So we started a prototype, and we're about 8,000 lines in when we found that the Chrome Apps guys were doing the same thing.
Yeah, so it's not often that you write 8,000 lines and then figure out that another team is pretty much working on the same project. So Devon and I met like 8 months back, and we realized that each of us had prototypes, but we had like shared goals here. We wanted to provide a great developer experience cross-platform. And we decided to combine forces and instead do a single developer environment that targeted both the use case of building Chrome apps as well as web applications, both in JavaScript as well as Dart. So this was around 7 months back, and we decided to drop our prototypes and start from scratch. So in the next 20 minutes or so, we'll give you a glimpse of what we went through in the previous 7 months, right? So the way we're going to do this is we'll be building the Chrome Dev Editor on stage from scratch. We'll do this piece by piece, and with every piece, we'll introduce a problem that you as a web developer might face, and we'll talk about a solution that the Chrome platform provides, and then how we use that solution in the Chrome Dev Editor. So let's get started on this journey. Devon is going to be rocking, start from scratch, pray to the demo gods.
Okay.
So how about starting with a simple, basic text editor?
Awesome, okay. So I'll switch over to my Chromebook. So this is the Chrome Dev Editor. It's a very stripped down version of it. What you're actually looking at it is it's editing its own source code right now. And over the course of the next 30 minutes, we're going to be adding features to it, using it to modify its own source code, restart, cross our fingers, and come up with a more improved version. And hopefully by the end of the talk, we'll have the full deal back. So the editing component we're using in the Chrome Dev Editor is the Ace code editor. For those of you not familiar, it's a JavaScript library, and CDE is obviously written in Dart, but Dart has a very strong JS interop story, so it's easy for us to consume best-of-breed JavaScript libraries. Ace gives us good editing for CSS, HTML, Dart, and JavaScript. It's fast and it looks nice.
Awesome. So it was fairly easy to get started because of Dart's JS interop story. We were able to reuse an existing JavaScript library that pretty much gave us the text editor that we wanted. So Devon, you know what? Like most developers, it would be awesome if most developers could build applications with just one file, but we've got to support like multiple files, possibly folders as well.
Mm-hmm.
How about adding like a files and folders view to the Chrome Dev Editor? How do you go about doing
absolutely. We need one, and we're going to use Polymer to build that UI up.
Polymer, like of basic files and folders view, why can't you do that using plain HTML and CSS?
You can. There are a couple of reasons why we chose to use Polymer. The short answer is for maintainability, reusability, and some scaling issues. And the even shorter answer is div soup. So what is this? This is a files view component written as a series of nested divs. And there's nothing really inherently wrong with this. I've written my UIs like this in the past, and it's functional. But it has some issues, and those issues scale up, get larger as your code base grows. So a lot of these divs are not really semantic. A lot of them exist only for you to have places to hang CSS styles off of. And the CSS styles that you're using to style this component can leak out of this component and affect other parts of your UI. And similarly, other styles for your application can leak in and style this component inadvertently. The code you write to manipulate this component, the JavaScript or Dart, can develop bad dependencies on the structure of it. So you have tight coupling between your HTML and your code. And reusing this code is hard. So if I want to create another files view or a similar component, I can copy this HTML, hope I copy the right CSS, and then have two places to maintain things. So there's maintainability and reusability issues.
So you're saying this div soup is messy, it's not reusable, it's not maintainable, and Polymer promises to solve all of that?
Yes.
How's that?
All right. So Polymer, it's a whole bunch of technologies, but some of the things it does for you are it encapsulates your DOM structure. so that places outside your application don't need to see into your internal structure of each component. It scopes the CSS so your styles don't leak out and other people's styles don't leak in. And it essentially lets you create reusable components that you can share in your application and compose in your application. You can use other people's components. It brings really good, basically, software engineering principles to the web.
So what does the Polymer solution for the files view look like?
Let's see it. So this is it. It's a new DOM element, files view. It's a custom element. And you can use it in your HTML just like you would use divs or paragraphs or any other elements.
No kidding, just a single element? So where exactly is the source code for all of that?
There's a bit more behind it,
Okay.
we can see. So here is the Polymer implementation of our files view. You can see there's a clean separation between the structure of our component in the HTML, the style in the CSS, and the behavior in the Dart or JavaScript code. At the very top of the HTML, Polymer element name equals files view. That's where we're defining our new DOM element. The next line down, this template repeat, we're iterating over the children, the child nodes of each folder. So we're basically iterating over the files in a specific folder. And for each file in that files view node element, we're inserting a new DOM element. So this files view node is another Polymer element we've defined elsewhere. So you can see the code is more semantic. It's easier to read. And the attribute names are semantic, name, icon, and indent, and the element names are as well.
Awesome. So Devon, how about getting our hands dirty, praying to demo gods, and adding this live to the Chrome Dev editor?
OK. All right.
Let's see how this goes.
Switch over to my Chromebook.
Yep.
OK. All right, so again, this is the source code for the Chrome Dev editor. This is our main HTML entry point. This defines the Polymer structure for our application. We've pre-written the files view, so I'm just going to add it to our UI now. And add a tiny bit more. So you can see I just had to reference this files view code, and it's imported in our Polymer imports up here. So now I'm going to restart. Oh, yeah, that wouldn't have worked.
Thanks for pointing that out.
That would have been a short demo. OK, so all right, now I'm going to restart the Chrome Dev editor. This is some demo magic for the sake of the presentation to try and compress this into 30 minutes. It's going to restart, load up the new source, and hopefully, if you look on the left-hand side, we should see this files view on the left-hand side of that splitter. OK, awesome.
All right, so now that we had a multi-file text editor, when we started testing this on a Chromebook, the process was quite painful. And one thing which was really hard was getting files in and getting files out of the Chrome Dev editor. We had to zip a whole set of files, email it to ourselves, extract it on Chromebook, and then point the Chrome Dev editor at it. So we really wanted to break boundaries here and make it really easy for getting files in and getting files out of the dev editor. So Devon, what do developers normally do for this kind of stuff?
Yeah, so they're going to use Git for that. They're going to want to clone a repo from GitHub and make local commits and push their pull requests back up.
Don't you need like a command line to type your Git commands? How does that work on Chromebook?
Yeah, it's not going to work great, but Git was such an important use case for the Chrome Dev editor that we decided to build Git support directly into the tool. So we wrote our own Git client library in Dart, which can speak the Git protocol to Git servers and manipulate the file system just like the Git command line client would.
Let's show that.
OK. So to add our Git library is pre-written, and it's hosted on our package hosting site, pub.dartlang.org. So what I'm going to do is I'm going to add a reference to that to our pub-spec file, which is part of Dart's technology. It's a declarative manifest of all the dependencies of your application.
That's a lot of dependencies that we have there.
Yeah, so the Chrome Dev editor has about 24 direct dependencies on various open source libraries, and another 24 transitive dependencies. But Pub lets you specify your version constraints very well, and it helps you work at a large scale application.
All right.
All right, so I will add a reference to our Git library. And I'll spell it correctly. So now we've basically told Dart's Pub Package Manager we want this dependency. I'm going to run pub get, which will go to pub.dartlang.org and provision that package locally. All right, so now it's in our source base. I'm going to add a little bit of pre-written UI to reference that library. Again, I'm going to use Polymer to do this. So git clone button and restart the Chrome Dev Editor.
Well.
And if you look in the toolbar on the upper left, hopefully we'll see a new button. Awesome. Okay, so that's that.
So is that going to work, git clone?
Well, let's find out. I have a canned repository. This is actually a JavaScript Chrome app written for I/O this year. You can try this Chrome app out at the Code Lab. So if I clone, this is actually speaking to GitHub right now. And cloning. Ah, awesome.
All right.
Okay. So this is just a regular JavaScript Chrome app. And I'll run it just quickly to show you what it does. It's a tic-tac-toe game.
Got it.
There we go.
Awesome. So that's Git working on a Chromebook.
Right.
So what Devon just showed you was the use of Dart's package management system, pub. So with pub, you can not only manage your dependencies well, you get access to a whole set of libraries, including Git, that we've contributed to pub recently. So now that we have a multi-file text editor with Git kind of built in, let's figure out what our next milestone was. We call this bootstrapping, and this was really an important internal milestone for us. And what I mean by bootstrapping is we wanted our software engineers to start using the Chrome Dev Editor on a daily basis to build itself. This was really important because this was dogfooding our own product. We could find lots of issues at dev time, and the big fun part of this was that our developers find issues and fix it themselves. We ran into lots of issues during dogfood, and you want to talk about some of the stuff that we fixed?
Yeah, dogfooding was very important to us, and we started dogfooding very early, probably even earlier than was really possible. And the main issue we found when we were writing code was basically we didn't have static analysis. We didn't have errors and warnings showing up as we typed code, and we're really dependent on this, and it meant that we found our errors at runtime or after we deployed it to the web store. So basically, we really needed Dart static analysis running in the Chrome Dev Editor.
So we'll show you how we added Dart static analysis.
Okay. So similar to the Git library, we're going to add a new package to the Chrome Dev Editor. Now this is a Dart static analysis package, which is again available for anybody to use. Analyzer, any. So we've declared that dependency. I'm going to run pub-get and download it from pub.dartline.org. Okay, cool. So there's no new Polymer UI for this. I'm going to restart the Chrome Dev Editor, though, and show you some changes to our Dart support. Okay, so actually, you do see these new these warnings on the left-hand side of the files view. We run the Dart analyzer in a web worker, or in Dart it's an isolate. We run it in parallel. It uses fairly heavy processing. We don't want it to interrupt the DOM thread. You see we have a warning on this file called deathstar.dart. It's not normally part of our source space. It is for the purpose of this demo. And the warning is on this constructor. It says the final variable deathstar must be initialized. So we have this variable. Declared it final. We never passed a value into it. I'm going to do that now. And you see errors and warnings show up and go away as I type. So that was a very powerful feature. Thanks. It seems very simple, but it was the single biggest impediment to us bootstrapping the tool. So we have a few other features we get from having static analysis. We have good knowledge of the code base, so we can have an outline view.
If you can resize that.
If I can resize it. You can quickly know what your code base looks like and jump to it. We can jump to definition. So if I want to see where this death star is defined, I can control-click it and jump to the definition. It makes a lot of sense. As your code base scales, you want to jump around different files and navigate it easily.
So Dart really takes developer productivity to a new level because it's a structured programming language. So Devon, you've spoken a lot about Chrome apps so far. What's the web app support in Chrome Dev Editor?
Absolutely, yeah. So web app support is obviously equally important. And I'm going to demonstrate number 4 here.
Yep.
So we have a number of project templates to help you get started with applications. I'm going to create a new web app from one of those templates. So we have several web templates you can use, a Chrome app, some Polymer support. I'm going to use a template called the Web Starter Kit, which was just introduced at Google I/O this year as well. It's basically a best practices web kit to help you get your application created quickly and keep it on the rails in terms of performance and jank-free code and running across multiple devices, so desktop and tablets and phones. So I'll create this application. And it's created. HTML, hit run, and cross my fingers. There we go. Okay.
Awesome. So the web page is actually running, on your Chromebook from within the Chrome Dev Editor. How is that working actually?
Yeah, absolutely. So obviously, a web page needs a server to talk to. We built a web server into the Chrome Dev Editor, built on top of the Chrome APIs, Chrome App APIs. Again, they're very powerful. They give you access to things like native sockets. So we built a web server on top of that. So makes it very quick to get started with the web app and prototype, and you can always move over to your own web server at some point. So.
All right, so it's not only Git that we built, we also built a web server in the Chrome Dev Editor, which works on a Chromebook. Let's move on. So this is a trick question for you, Devon. There's something that's really hard for developers these days, and especially at I/O this year. You know what that is?
The giveaways.
Talking about mobile, yeah, mobile is on fire, and there are any number of graphs to show, what the growth curves are. But this one in particular shows you the explosive growth that mobile devices have had over the past couple of years, especially smartphones and tablets. So if there's one platform that you need to target, it's got to be mobile. You've got to be building mobile first these days. So Devon, like Chrome Dev Editor mobile, can we come up with a really dead simple mobile development workflow?
Yeah, absolutely. Mobile, we knew mobile was going to be an important use case when we started designing this tool. So we built mobile support into Chrome Dev Editor. In fact, we made it as easy to run an application on your mobile device as it is to run locally. So I'm going to demonstrate adding some mobile UI to the Chrome Dev Editor. Let's see, mobile deploy. So this is pre-written UI.
It's Polymer in action again.
And I'm going to restart. And if you look at the toolbar, hopefully see a 4th button up there. Mobile deploy. OK, awesome. Let me find that application we cloned. So this is the Chrome app we cloned earlier. I'm going to hit this new mobile button. It's going to show me a dialog, deploy to mobile. I'm going to hit that, but let's switch over to my phone real quickly. So this phone is connected to my Chromebook via USB. I'm hitting deploy now, and it's updating. And
fingers crossed.
Well, all right. It's not totally happy. Let me try once more. Okay, yeah.
All right, so I think we ran into an issue where the background changed to black, instead of showing the tic-tac-toe game, but I assume that worked. Yeah. So what you now have is Chrome apps running on mobile, and let's switch to slides. So Chrome apps not only work on desktop operating systems, but they also work on mobile platforms. So this is made possible with an open source framework called Apache Cordova. So we've been contributing to this project for more than a year now, and we've contributed several Cordova plugins which provide really interesting mobile capabilities, ranging from accessing your accounts on your phone to having a native payment flow to getting messages sent over using Google Cloud Messaging. So now with all these awesome native capabilities, we also have a great developer workflow that lets you quickly deploy your mobile applications from Chrome Dev Editor running on your Chromebooks onto your Android device. So, Devon, you think we can talk about the debugging story for mobile apps?
It's going to be tough if it didn't
Let's give it a shot.
It did not come up on this, so but I'll give it a shot. So
Can thank Michael for that.
so our debugging story for Chrome Dev Editor is just using DevTools. It's a fantastic debugger, and it has great support for mobile too. So we'll bring up DevTools. We're going to accept. Actually, I should probably switch over to my.
Sorry.
Awesome. Okay, so I'm looking for something that says tic-tac-toe. Yeah, I'm afraid this is not going to fly. Yeah. Okay. Okay. Oh, tic-tac-toe.
Oh.
Awesome. All right, so.
Hold on, let's show the wolf vision. So yeah, that's the app which magically came up again.
Okay. So.
I skipped a couple of beats, but.
Yeah, no, I didn't. All right, cool. All right, so.
So let's go back to
the debugging.
Yeah.
I'm going to bring up a DevTools inspector on this. Yeah, it's not cooperating. Anyway, so our development story with Chrome Dev Editor, especially on mobile, is DevTools.
Yeah, so DevTools really complements Chrome Dev Editor. DevTools provides a great debugging story, and you have a great development experience with Chrome Dev Editor. So to sum it up, what we've shown you is Chrome Dev Editor was built on the Chrome platform, Chrome Apps, Dart, and Polymer. Chrome Apps really provides the native capabilities that you need, and you can target multiple platforms, not just limited to desktop, but also Android and iOS. With Dart, you get awesome developer productivity because it's a structured programming language. And with Polymer, you get the ability to encapsulate your elements so that you can build your own custom HTML elements that you can reuse across your projects. So the Chrome Dev Editor itself has been open source since day one, and you can check out our source code to find out how we use these three parts of the Chrome platform together. So Devon, you want to talk about some of our external contributors?
Yeah, absolutely. Yeah, so like Sriram said, we've been open source since day one. We've had only over 20 contributors, that's both Googlers and non-Googlers. I'd actually like to thank our two biggest non-Google contributors, Adam and Sungok.
Yeah, thanks a lot, folks, and I really hope that many of you can start contributing to the Chrome Dev Editor as well. So if you're interested in building apps for the Chrome platform, check out our documentation. I'm also happy to announce an early developer preview version of the Chrome Dev Editor, which is available from our GitHub site. So there's a link which takes you to the web store, and you can install the Chrome Dev Editor on your Chromebooks right today. And not only that, at Google I/O, we have several code labs which use the Chrome Dev Editor. You can check them out there as well. And Devon and I will be at the Dart booth. We'll also be at the Chrome booth, so come talk to us to know more about the Chrome Dev Editor. It's at an early stage, so we'd love to hear from you what feedback you have on the current working version of the Chrome Dev Editor, what features you would like to see, and more. Thanks a lot for coming to our talk. Hope you enjoyed it. So there are mics on either side. You can come over to the mics and ask your questions.
Hi, I was wondering where the file system is hosted, and does that scale to much larger web projects?
Yeah, so we're just using the Chrome App APIs basically give you fairly good access to the file system. So the user selects a folder, and then you can see everything in that folder and below it. So we're just using the regular the Chrome file system, and it scales up to whatever size disk you have.
Okay, so when you're cloning, it does actually bring the files local to the machine,
Absolutely.
not hosted on a server somewhere?
Nope, yeah, they're local. You can disconnect your network and run just like a regular native app.
So we are working on a feature which would allow the files to be backed up by Google Drive. So it's using the Sync File System API. So that's a feature we'll add pretty soon. So that will allow you to like have your files on Google Drive and sync automatically across machines.
Awesome, thanks.
Yep.
Hey, I was wondering if Dart is running natively on any of these devices, platforms.
So this is actually the Chrome Dev Editor compiled to JavaScript. Our story right now is that we're developing against Dartium, a Chromium version with Dart natively. It's a very good development story. When we're deploying the Chrome Dev Editor, it's compiled using Dart2JS and distributed that way.
Right. Thanks.
Things like Node and Grunt are a big part of my workflow. Is the Bash shell supported in Chrome Dev Editor?
Yeah, so the Bash shell is not. We have to figure out how better to support a good JavaScript development workflow. We have Bower support built in. That was important to support Polymer well. We need to be able to provision their dependencies using Bower. We still have to figure out how we're going to support common JavaScript workflows like Grunt.
So we are working with a native client team to see how we can like run native code within the Chrome Dev Editor, and hopefully that would allow us to like support some of the native tools that you're talking about.
Thanks. And are there any plans to bake this directly into Chrome alongside DevTools?
So right now it's a separate app that you need to install. We want to keep it that way because it allows us to iterate outside of Chrome much faster. So it's just one install away, and it synchronizes across all your Chrome profiles.
Thank you.
Are you have anything like push to app engine?
So we are going to work on App Engine support. Actually, it's very easy to support a deploy theoretically, because App Engine you can do a git push to a specific URL, and it deploys your application, and we support Git. So we'll probably go that route at some point.
All right, cool. Thanks a lot, folks. Looking forward to your feedback.